Hello everyone, this is Ajay and you are welcome on my YouTube channel which is Math Cafe. So this one is the part 5 of our topic which is matrix. So this video is all about multiplication of matrices. So first of all we will see some points. First point is matrix multiplication AB is possible if we are multiplying a matrix A by matrix B. So matrix multiplication AB is possible when number of columns in matrix A should be equal to number of rows in matrix B. Alright. So matrix multiplication of two matrices A and B is possible when number of columns in matrix B is equal to number of rows in matrix A. Alright, if we are multiplying two matrices A to B, then this multiplication is possible when number of columns in A should be equal to number of rows in matrix B. Let's say a matrix is of order M cross N and matrix B is of order P cross Q. So this matrix multiplication is possible when number of columns in matrix A should be equal to number of rows in matrix B. So first of all N should be equal to P. Alright. And second, the matrix multiplication, if we are multiplying A by B, then the order of the matrix AB will be M cross Q. Alright, so first point is clear. Let's move to the second point. In the second point we will see that matrix multiplication is done by row by column method. Alright, so matrix multiplication is done by only row column method. Actually we have seen in determinant before that we can multiply two determinants by four methods: row by row, row by column, column by row and column by column. But matrix multiplication will be done by only row by column method. So let's move to the third point. If we are multiplying A by B, so if AB multiplication is possible, then matrix A will be called prefactor and matrix B will be called postfactor. Alright, so that is all about the multiplication of AB. If multiplication BA is possible, BA is possible, so what will be the condition if multiplication BA is possible? So here B is of order P cross Q and A is of order M cross N. So this multiplication is possible when number of columns in matrix B should be equal to number of rows in matrix A. So first of all Q should be equal to M. And second point is that the multiplication matrix BA will be of order P cross N. Alright, so let's see some examples here. So first example is, if a matrix, any matrix A is 2 1 2 1 minus 1 and 0, and matrix B is let's say 0 1 3 5 2 minus 6 3 2 1. Alright, and we have to find multiplication of AB if it is possible, and we need to find multiplication of BA if it is possible. So matrix A is of order 2 cross 3. There are number of 2 rows and number of 3 columns, and matrix B is of order 3 cross 3. Alright, so let's proceed with the solutions. First of all, we will check that multiplication of AB is possible or not. So multiplication of AB matrices is possible when number of columns in matrix A should be equal to number of rows in matrix B. So A is of order 2 cross 3 and B is of order 3 cross 3. As we can see that number of columns in matrix A is equal to number of rows in matrix B. So matrix multiplication AB is possible. So let's proceed. So we'll multiply matrix A by matrix B. So A is 2 1 2 1 minus 1 0, and matrix B is 0 1 3 5 2 minus 6 and 3 2 1. Solve this matrix multiplication by row column method. Alright, so this is of order 2 cross 3 and this is of order 3 cross 3. So matrix multiplication AB will be order of 2 cross 3. So this will be of order 2 cross 3. Alright. So we will solve it by multiplying row by column method. So 2 will be multiplied by 0. 2 multiplied by 0. Alright. And plus 1 will be multiplied by 5. 1 multiplied by 5. Plus 2 will be multiplied by 3. 2 multiplied by 3. Alright, this is first element, and first row will be multiplied by second column. So there will be 2 multiplied by 1 plus 1 multiplied by 2 and 2 multiplied by 2 plus 2 multiplied by 2. And third element will be, we will multiply row 1 by column 3. So we will get 2 multiplied by 3 plus 1 multiplied by minus 6 and 2 multiplied by 1. Alright. In the second row, we will get terms 1 multiplied by 0 plus minus 1 will be multiplied by 5 plus 0 will be multiplied by 3. Alright, and second row will be multiplied by second column. So we will get 1 multiplied by 1 plus minus 1 multiplied by 2 plus 0 will be multiplied by 2. And in the last, we will multiply row 2 by column 3. So we will get 1 multiplied by 3. 1 multiplied by 3 plus minus 1 multiplied by minus 6 plus 0 multiplied by 1. So let's solve it. So this will be 0 plus 1 multiplied by 5 will become 5 plus 6. And here 2 plus 2 plus 4. 6 minus 6 plus 2. Here 1 multiplied by 0 will become 0 minus 5 and 0. 1 minus 2 and 0. Here 3 plus 6 and 0. Alright. So let's proceed. Finally, we will get multiplication of AB, that is of order 2 cross 3. 5 plus 6 will become 11. 2 plus 2 4. 4 and 4 8. 6 minus 6 will become 0. 0 plus 2 is 2. That is minus 5, minus 1 and 9. So that is the multiplication of AB. Let's check if multiplication BA is possible or not. In the second part, we'll check multiplication of BA is possible or not. So B is of order 3 cross 3 and A is of order 2 cross 3. B is of order 3 cross 3 and A is of order 2 cross 3. So multiplication of BA is possible when number of columns in matrix B is equal to number of rows in matrix A. So here 3 is not equal to 2. So we can say that this multiplication is not possible. Alright. So hope you understand this. Let's proceed with the next example. If it is given that A is of order 2 cross 2, B is of order 3 cross 2 and C is of order 2 cross 3, then we need to find total number of possible multiplications. Alright, so let's proceed with the solutions. So first of all, we will see that multiplication AB is possible or not. So AB multiplication is possible when number of columns in A should be equal to number of rows in B. So number of columns in A is 2 and number of rows in B is 3. So this multiplication is not possible. We will see multiplication of AC is possible or not. So AC is possible when number of columns in A should be equal to number of rows in C. So this multiplication is possible. Alright, next we will see that multiplication of AA is possible or not. So multiplication of AA is possible because number of columns in A is 2 and number of rows in A is 2. Alright, so number of matrix multiplication AA is possible. Let's proceed with multiplication of BA. So multiplication of B is possible when number of columns in B should be equal to number of rows in A. So number of columns in B is 2 and number of rows in A is 2. So this multiplication is possible. Next we will see multiplication of B to B. So B to B is not possible because number of columns in matrix B is 2 and number of rows in matrix B is 3. So this multiplication is not possible because number of columns in B should be equal to number of rows in B. Alright, we will see multiplication BC is possible or not. So number of columns in matrix B should be equal to number of rows in matrix C. So number of columns in matrix B is 2 and number of rows in matrix C is 2. So this multiplication is possible. So let's proceed with C multiplied by A. So number of columns in matrix C is 3 and number of rows in matrix A is 2. So this multiplication is not possible. We will see that multiplication CB is possible or not. So number of columns in C is 3 and number of rows in B is 3. So this multiplication is possible. We will see that multiplication of C to C is possible or not. So as you can see, number of columns in matrix C is 3 and number of rows in matrix C is 2. So C to C multiplication is not possible. Alright, so next we will see some properties based on multiplication of matrices. First property is matrix multiplication AB will not be equal to BA in general. Alright, and second point is if any matrix A is multiplied by B plus C, then we can write it as A multiplied by B plus A multiplied by C. Alright, and this is called distributive law. Alright, and in the third point we will see that if AB equal to BA, then A and B are called commutative to each other. Then A and B are commutative to each other. Alright, so if AB equal to BA, then A and B will be called commutative to each other. And in the fourth point, we will see that if AB is equal to minus BA, then A and B will be called anti-commutative to each other. Then A and B are anti-commutative. This is anti-commutative or anti-commute to each other. Alright, in the fifth point, we will see that if any matrix A is multiplied by 0 matrix, that will become 0 matrix. Or if any 0 matrix is multiplied by any matrix A. Alright, in the sixth point, we will see that if any matrix A is multiplied by identity matrix, then resultant matrix will be the matrix itself. Or any matrix identity matrix is multiplied by A, then resultant matrix will also be the same. 7 point, we will see here that determinant value of AB will be equal to determinant value of A and determinant value of B. So this will be same if A and B are square matrix, right? If A and B are square matrices. Because we will find determinant value of only square matrices. In the 8th point, we will see here that if it is written A square, then it means A multiplied by A. If it is written B square, it means B multiplied by matrix B. If it is written A square B square, alright, that means A multiplied by A and B multiplied by B. So A multiplied by A and B multiplied by B. And it is written AB whole square, that means AB multiplied by AB. Or we can write it as AB multiplied by AB. Alright, so we can deduce that AB square will not be equal to A square B square. Both the terms are different. Hope you understand this. In the 9th point, we will see that if any matrix A plus B whole square. So for A plus B whole square, we will write it as A plus B is multiplied by A plus B. So with the help of distributive law, we can write it as A multiplied by A plus A multiplied by B plus B multiplied by A plus B multiplied by B. So A multiplied by A plus A multiplied by B plus B multiplied by A plus B multiplied by B. Or we can write it as A square plus AB plus BA plus B square. Alright, hope you understand this. Next, if A minus B whole square, then we will write it as A minus B is multiplied by A minus B. With the help of distributive law, I will write it as A multiplied by A minus A multiplied by B minus B multiplied by A, and minus minus will become plus B multiplied by B. Or this can be written as A square minus AB minus BA plus B square. Okay, so in the 10th point, if I put a condition that if AB equal to BA, AB is equal to BA, that means A and B are commutative to each other, then A plus B whole square will become, in this case AB and BA are same, so A plus B whole square will become A square plus twice of AB plus B square. A minus B whole square will become A square minus twice of AB plus B square. Okay, and A plus B whole cube will become A cube plus b cube plus thrice of ab multiplied by a plus b, and a minus b whole cube will become a cube minus b cube minus thrice of ab multiplied by a minus b. All right, and in the last we will see that a plus I raised to let's say power n. So this will become nc0 a raised to n plus nc1 a raised to n minus 1 plus nc2 a raised to n minus 2 and so on, ncn a raised to 0. That means I can write it as I, identity matrix. All right, let's see one last point, 11th. If AB is 0, that doesn't mean that A equal to 0 or B equal to 0. So this one is the important point. Let's see a question here. Question is that predict whether true or false. So I will write some statements. You will have to answer that the given statement is true or false. If first statement is written that if A equal to B, that means determinant of A will be equal to determinant of B. So if two matrices are equal, then their determinant value will be equal. So I can say that this statement is true. In the second statement, it is written that if determinant value of two matrices are equal, that means both the matrices will be equal. So determinant value of two matrices are equal, that doesn't mean that both the matrices are equal. All right, so this statement is false. In the third statement, it is written that if A square is equal to B square, that means A will be plus minus of B. No, that is false. All right, so this is my matrix multiplication. We are not using all the formulas of algebra. In the fourth point, it is written that if matrix multiplication AB is 0, that means matrix A equal to 0 or matrix B equal to 0. As I said, we are not using all the formulas of algebra. So if AB equal to 0, that doesn't mean that A equal to 0 or B equal to 0. So that is statement false. So in the fifth part, it is given that if two matrices are equal, if A equal to B, then A plus C will be equal to B plus C for any matrix C. So this is possible because if I will transfer this C in left hand side, then C minus C will become 0. All right, and if I add any 0 matrix in any matrix, then the resultant value will be the matrix same. So we will get A equal to B finally. So this statement is true. Let's see point number 6, sixth statement. If it is written that A plus C is equal to B plus C, that means matrix A is equal to matrix B. So as I said that C can be transferred in left hand side, so C minus C will become 0 matrix, and if I add any 0 matrix in any matrix, then the resultant value will be the matrix same. So we will get A equal to B. So this statement is also true. So in the seventh part, it is given that if two matrices are equal, if A equal to B, then if you multiply any matrix C, then AC will be equal to BC. So this statement is true. So we can either post multiplied by any matrices or pre-multiplied by any matrices on both sides. So this statement is true. So in the eighth statement, it is given that if AC equal to BC, that means A equal to B. That is not true. That is false. Alright, we cannot just cut C matrix on both sides. So this statement is false. So in the ninth statement, it is given that if A is equal to B, that means AC is equal to CB. So this statement is false because we can take any matrix C as a prefactor or post factor, because in this matrix multiplication C is post factor and in this multiplication C is prefactor. So that cannot be done. So in the last 10th sentence, it is given that if for any matrix determinant value of matrix A is 0, that means that matrix is 0 matrix. This is false. Hope you understand this lecture. If you have any doubt, you may ask in the comment section. So see you soon in the next video. Till then, bye, take care and keep learning.